All right. So instead of going over a quadratic formula today, we're going to talk about graphs of quadratic equations because I feel that's going to be more relevant to where you guys are going to be spending a lot more time in Algebra 2. Of course, we're only going to talk about one day of transformations, and we'll kind of reinforce it tomorrow. But it's such a big part of Algebra 2 that I feel like we should have that discussion on transformations. So what I'm going to do is I'm going to go to the Chapter 4 notes. We're actually going to talk about probably the first, how many pages? That's a lot. I don't want to overwhelm you guys too much information. Well, let's see. 8 pages is a lot to do. Let's see how far we can get. Because I think, but some of this could go fast. So we're going to talk about graphs of quadratic equations, right? So like y equals x squared. That's the most basic quadratic equation you can think of. And it's really simple. If you just plug in these numbers into x squared, you should get 9, 4, 1, 0, 1, 4, 9, right? If you square a negative, it's positive. You square positive, still positive, right? So there's symmetry. Symmetry is a big part of quadratic functions. So you plot the points. And there you go. Axis symmetry divides the problem into two pieces, which are mirror images of one another. That's what symmetry means. On the parent function, axis symmetry is line x equals 0. So it looks just like this. It's just a vertical line that goes straight up and coincides with the y-axis. That's your axis symmetry. The vertex is the lowest point in this case. It could be the highest point if it's opening down, but since it's opening up, our vertex here is 0, 0. So that's my vertex. There's word problems that deal with this stuff. I don't know if we'll get into that in this class, but it's good for context and help you understand how vertex can be assessed in a word problem. That's kind of good. Yeah, x-intercept is kind of the same thing. So we might talk about word problems maybe tomorrow if we get a chance. I don't know if we'll get to that today. And tomorrow we're doing more review anyway, I suppose. So questions on that one? Pretty standard. And we call it the parent function because it's the most basic quadratic function you can write. There's no x, there's no number like 1 or 2, there's no negative in front, there's no coefficient. It's very plain, vanilla, just y equals x squared. That's it. And that extension does go to the vertex. Now, let's talk about a change. When you transform, you change, right? So here's a change, a vertical stretch. So this is pretty easy, right? That's what we just did in the previous problem, right? But what if you put a 2 in front? Now, very careful. Because 2 times x squared, does that 2 get squared? Or did you square first? Times us. What do you do? Do you square first or multiply 2 first? X. You square, right? Count e, right? The e comes before the m. So you square it, then multiply 2 afterwards. So what it does, all the y values get doubled. Because you square first. So if I plug in another 2, I get 4, but then multiply by 2, I get 8. Then I get 2, still 0, 2, and 8. So if I do the original in red, should have wrote those in red as well, but that's okay. Here we go. Now let's do the transformed one in green. See how it gets skinnier? So the vertical stretch, the graph gets narrower. As it should, because you're stretching it vertically, right? It should get narrower. So the vertex is still 0, 0. Axis symmetry is still 0, x equals. That didn't change. We just made the graph skinnier. That's all, or narrower. Or you can think of it like this. It's not really slope. But kind of is. That's because the graph gets steeper. Right? I've definitely made this a steeper graph. 100% I have. Okay, same thing here. 9, 4, 1, 0, 1, 4, 9. Now, reflection means a flip, not like reflection reflecting on your life or about society, but reflection in the sense it's flipping over, right? So that's all that's happening. So you multiply by -1. All y values change sign. So now it's going to be this: -9, -4, -1, 0, -1, -4, -9. I won't do the parent function because now you know how it looks. There we go. Easy peasy. Axis is still x equals 0. Sorry. Vertex 0, 0. My bad. Just not paying attention. My apologies. And x equals 0 for axis symmetry. So those are two very easy transformations. You can always go to Desmos and play around with it a little bit. Now, there's a typo here. I don't know why. We need to change this table. This is weird. I don't know why that's that. I'm going to rewrite that column as this. And then I'm going to make another column that's like this. Actually, hold on a sec. You know what? Let's back up a little bit here. Let's just get rid of this entire column. We'll call this y equals, we'll call this the parent. And then the transformed. Okay. Parent we know again is this: 9, 4, 1, 0, 1, 4, 9. And actually, I will graph it because I want you to see how it changes. Okay, so x minus 3 squared minus 5. For a moment, let's actually go to Desmos. Y equals x squared. Cool. Now, if I do +1, I think we talked about this the other day. That goes up 1, up 2. Because you're adding numbers to the original y value. Up 3, up 4, -1, -2, -3, -4. But if you do something on the inside, this is where it gets a little weird. It's a bit counterintuitive. If I do x minus 1, it actually goes 1 right. You see a -1, you think it goes 1 left. It does not go 1 left. It goes 1 right. The reason it does that is that you have to plug 1 in for x to achieve the same y value as when you plug in 0 for x squared, y equals x squared. For y equals x squared, you plug in 0 for x, you get 0. That's the output. If you want to guarantee the same output for y equals x minus 1 squared, you got to add 1 x, not subtract. Counteract that -1. So if I do -2, goes 2 to the right. -3, 3 to the right. -4, 4 to the right, and so forth. Right? 2 right, 3 right, 4 right. Now if I put +1, oh, it goes left, 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 left. That's what's happening. So generally speaking, we think of a quadratic function like this. We'll talk about it in just a second. We kind of think of it like this here. And this is going to be groundbreaking. It's the most important thing I think you get out of algebra 2 is the transformations. H is what we call the horizontal shift. Because it causes the graph to move horizontally. K is what I call the vertical shift. And we're going to have a discussion later in the notes. And A is what I call the vertical stretch or shrink. Also, it could be a reflection about x-axis if it's negative. So those are all things that are attached to the function that can transform the graph, that can change it. Absolute value graphs work the same way. Trig graphs work the same way. If you guys do like square root functions or any radical function that you're graphing, exponential graphs, something called logarithms, which we'll learn later in Algebra 2, any function you learn is going to really follow these kind of generalizations. This is one of the most important things you get out of Algebra 2. And this is being into almost daily. In pre-calculus, we put it in like crazy. By the time you get to calculus, you should be very comfortable with this. So it's one of the most important things we do. So I feel like I had to talk about this today because I wouldn't feel right if I didn't. So anyway, let me undo all this stuff here. I'm going to repeat it again because I don't want to redo the other stuff I just did. Okay, it's just going to take some sweet little time. Hope I don't kill my mouse doing this. Cool. So how does this graph get transformed? Well, the -3 meant we go 3 right. We know this now. The -5 means I go 5 down. Well, right, left deals with x, right? Horizontally deals with x. Vertically deals with y. So 3 right means I'm going to add 3 to x. 5 down means -5 to y. And that's what I did. This is the numerical process. Numerically, what's happening is I'm changing the x values 3 higher. So 0, 1, 2, 3, 4, 5, 6. I've added 3 to each of these here. But this, I'm going to subtract 5. So 4, -1, -4, -5, -4. It's all symmetrical too, as it should be. -1 and 4. So I plot those. 0, 4 is my new vertex. Sorry, I lied. I just have 0.04. I don't know why I said that. 1, -1, 2, -4, 3, -5 is my new vertex. That's what I meant to say. Because it's all about symmetry. And here we go. See how the graph shifted? Did it go 3 right? Yes. Did it go 5 down? Yes. You look at the vertex, it's a great way to compare. 3 right, 5 down. So the vertex is at 3, -5 now. And the axis symmetry, of course, is x equals 3. Easy peasy. Not that hard. Just have to practice and get used to this. Now you're asked to describe the transformation. So once you get good with this, you can kind of sort of just look at it and say, okay, well, this goes 5 left, reflect about x-axis, 4 down. Okay, so I know 5 left because now I talked about +5 with x. I know it reflects what x actually talk about negative flips over the x-axis. 4 down, I talk about -4 on the outside, and these goes 4 down. We've seen that now, right? Why am I particular with order? Am I just being incredibly OCD? Yes, I am being OCD, but I'm not an actual OCD person. But for this, I'm especially on. Why do I care about the order? Yeah, think about what we did on the first day here. Yeah, Emma? Thank you. About 100%. Yep. PEMDAS. You have to respect order of operations because think about when you're plugging in. What are you doing? You're working out. But y equals, right? How are you working out what y equals? PEMDAS, right? If I plug in order for x, what's the first thing I have to do? Add it to 5. Because I'm taking care of the parentheses. What's the next thing I do? X values. What's the next thing I do? Multiple. What's the next thing I do? -4. So the 5 left is on the inside. That has to be the first thing mentioned. Reflect has to be the second thing mentioned, and that's supposed to be the third thing mentioned. So if you don't follow this order, the graph will not be in the right place. if you were to actually literally take y equals x squared and move it 5 left, reflect, and then go 4 down, you get the right thing. If you mix it up, you get a much different location. So it actually does matter. And I don't bend on this at all. If you take me as an Algebra 2 teacher, I will take out points if you mess up the order. It is very important. So, because I want you to get the right answer, right? So some things I'm more lax about, but this I'm not. I'm very rigid about this. So let's look at the next one. The 1/2 you see first. So in this case, we're going to say, it's kind of weird. It's not really a stretch. It's a vertical shrink. Because think about it, you're multiplied by 1/2. It's not stretching. It's not getting skinnier. It's getting fatter, actually. So it's a vertical shrink by a factor of 2. I know it's weird. I'm being a little, what's the right word to use? Precise, I guess. Because it does shrink to, well, let me think about it. It gets a half its height, but you're basically taking the y values and dividing by 2. That's really what you're doing. So that's why I say by a factor of 2, because shrinking means dividing. So shrink actually means divide. Whereas stretch means multiply. I'm dividing by 2, not by half, because then that would be counterintuitive, right? So if I were to rearrange the y values or transform the y values, I divide them by 2 first, then add 7. That's why it's a shrink by a factor of 2. And we'll actually look at some graphs like that, I think, in just a little bit. Yeah, we will for B. That's good. Okay. I'm going to skip some of these because I think some of these are a bit redundant. I want to do B on the bottom page too. Let's not do A. Let's do let me zoom out just a tad so I can capture most of this. Okay. Let's not do A. Let's do B instead. So the parent function 4, 1, 0, 1, 4. Now, when you vertical, it's actually more of a shrink. So first of all, X is not actually, I kind of don't like this. This is confusing. Sorry, I didn't make these notes. Okay, so this is the parent. This is the transformed. I do 2 tables. That's how I do it. Okay, now let's look at X. Am I adding or subtracting anything directly to X here? So I have a parentheses like X minus 1 or X plus 1 now. So it stays the same. X does not change. There's no change to X. And remember, we have Y equals A X minus H squared plus K. H is 0. There's no change X. So I'm going to keep the same exact X values. Y. Okay. A is 1/2. K is 7. But remember, you do this first. You do this second, right? Because you always multiply for adding or subtracting. So you have to do multiply Y by half. Or I'm just going to say this. Divide Y by 2. That's really what you're doing. Then add 7. Okay. Divide Y by 2. Then add 7. So what's 4 divided by 2? 2. 2 plus 7. Yeah, actually, you know what? Let's do this. Let me do some black so it sounds a little better. So 4 I thought I did black. What the heck? Here we go. 4 over 2 plus 7. 1 over 2 plus 7. 0 over 2 plus 7. 1 over 2 plus 7. 4 over 2 plus 7. 9. 7.5. 7. 7.5. And 9. So just plot those points. -2 comma 9. It's really high. Um, 7.5 and 1. And of course 7. It does look a little fatter, right? It looks a little wider than y equals x squared. And it's shifted up, right? It's up by 7 units. So now you're kind of seeing the numerical and graphical connection, right? That's kind of important. We're okay? Good. All right, let's keep moving. I'm gonna have you guys try this one on your own to see how it goes. And then a lot of this gets pretty repetitive, but I'm gonna do B with you guys on page 5. Then maybe we'll take a break after that. So I think we'll do a couple more problems and we'll take a break. But for number 1 here, let me zoom out a tad. Nice, that looks good. So I don't like this, so I'm just gonna cross this off. So 4, 1, 0, 1, 4, that's your parents. The transformed. So notice how we're not really plugging in random values for x. I don't like that. I don't want to. Yes, we're doing a table, but we're being very calculating with how we're making the table, right? Very calculating about it. What you want to do is we're going to add 1 to x. And then for y, multiply y by -2, then add 3. Okay. So go and make the new table and go and graph it. And just graph the transformed. You don't have to graph the original. So all freeze my screen, do the same. And we'll check our answers. Okay. Here's what I got. Did I go 1 right? Sure. Did I go 3 up? Sure. Did I flip it? Sure. Did I stretch it? Sure. Did all those things. But I didn't have to think about those things as I was doing the graph. I just went about numerically, right? I had my parent, made the changes. A was -2. H was 1. K was 3. Because remember, the general formula is this. Okay. So I added 1 to x. The y values change in that manner by following PEMDAS, and I get the correct graph. Yes, I've done this a long time, so I'm going to be faster than you guys. But as you get more and more into this rhythm, and this will take time, it won't happen overnight. Like Trust me, that's why we do this over and over again. Because by the time you move on to advanced math, like pre-calculus, calculus, whatever, you gotta be comfortable with transformations. You guys gotta know, oh yeah, that's how it looks. And then you could apply whatever advanced math skills you've learned down the pipeline to those functions. So, and this is, by the way, a huge deal on the SAT or ACT. There's actually creative ways they assess this. Let's see if I can find some problems maybe after the break that might be good to share. Let's not do B. That's fine. All right, let's move on to page 5, part B. Now, this is factor form. We call this factor form. Or intercept form. So I'm going to find my x-intercepts first. Let's do that first, because that should be easy to identify. What would make them 0? What would make that 0? First factor. On the second one. Boom, done. Great. That's easy. So x-intercepts are 3 and -1. So there you go. Okay. Now this is the fun part. This is where I get highly analytical. This is the one, algebra 1, I'll not, yes, you guys. It's kind of, not rote memorization, but it's a lot of repetitive skills, right? Algebra 1, like rinse and repeat, let's do these over and over again, just to build skills, right? Geometry, we do some abstract reason, right? Totally we do, like the shapes, you got visualized, you know, we're trying to get you guys to think a little differently. Algebra 2 is highly analytical, highly analytical, because once you have this, what can we glean from that, right? Like, so to think about it, what would be my axis of symmetry? What line would go right between those two dots? X equals what? 1, yes, exactly. X equals 1 goes right through the middle. So I know my axis of symmetry right away. Because I'm using symmetry, right? Totally, 100%. Has to. You have to have mirror images of each other. They have the same y value, you know, the x-intercepts. So my vertex, what's going to be the y coordinate? Sorry, what's going to be the x coordinate of my vertex then? Has to be right, has to be on the axis of symmetry, right? So it has to be 1. The axis of symmetry has to be 1. Where it is exactly, is it here? Is it here? I don't know yet. How do I find the y value that goes with it? What would I do? I have an equation. What should I do with that 1? Plug in. Exactly. Good. Yes. -2 times 2 is -4. So that's my vertex. Now I can do the graph. There you go. I got enough points to do the graph. I'm good. I like, this is actually even easier when it's written this way, as opposed to what we've just done for the last 15, 20 minutes. I think this is easier because now you got x-intercepts right away because it's this factor form. Take the average of the x-intercepts, plug that number into the equation to get the y coordinate, you're good. The y-intercept's easy. Just plug in 0 for x. That should be -3. That's easy, which I kind of show right here. The minimum y value, of course, is -4. It's a minimum, right? I'm gonna come back in domain and range in just a little bit. If I put it in vertex form, it's y equals x minus 1 squared minus 4. Because I went 1 right and 4 down. Remember, we went 1 right and 4 down. And there's no a value, because you don't see a number out in front here. If you had a 2 in front, then a is 2, but we don't see that, so you assume it's 1. Standard form is when you distribute or FOIL. Standard form is just this: ax squared plus bx plus c. Okay. Now let's talk about domain and range. Domain is for x, range is for y. Come on, different colors. Let's go. Here we go. What are the x values here? I'm sorry. let me rephrase that. What are the valid x, or are there any x values that I can't do, or can't do any x value I want? Can I plug whatever I want for x? Is there any need to restrict? Do I have like a radical where I can square negative numbers? Do I have a fraction where I have 0 on the bottom? No, right? Look at the graph. X can be whatever you want it to be. So it's all real numbers. You can do whatever you want for x. But look at y. What's the lowest y value here? -4. You're going above. All's good? Okay. Let's do one more of these and we'll take a break. Go and try part D on your own. I'll give you guys a few minutes to do that. Then we'll share. And then we'll take a break. I'll freeze the screen. Okay, well, I did it fast, but here we go. So that's a full analysis of the graph. X-intercepts, -2, -6. X-intercepts right in the middle. Therefore, is x from the vertex, plug back into get 4 for y. That's an axis, is up and down. So the highest y value is 4. Meaning the range is y is less than or equal to 4. That means all real numbers. Plug whatever for x. Y-intercept is plugging 0 for x. You should get -12 for y. Vertex form. Well, I know my vertex is -4 form. Oh crap, that's wrong. What the heck was I talking about? Sorry about that. I knew it was not gonna be perfect. There we go. But you keep the same a value. A is -1. So you have that, and then you just distribute FOIL. You should get that as your standard form. So we're gonna practice this when we come back from the break. So it's gonna take a break right now. We'll come back around 10:10. There's still a couple more things I want to talk about from these notes that I think are important. Let me hit pause. Okay, guys, here we go. So let's go to page 7 of these notes. And we're going to write equations from the graphs or from the points you're given. And maybe just kind of do a couple other problems on page 8, and that's it. So vertex form is this. Everybody mentioned it before. If y equals a, x minus a squared plus k. So it's pretty clear the vertex for a is right here. And what's what are the coordinates of that point? 2, 1. You also have another point at 3, 0. Page 7. They were on page 7 of the chapter 4 notes. So you should have y equals a x minus 2 squared plus 1. Then if you plug in 3 and 0 for x and y, and solve for a, oh, I'm sorry. My bad. I was recording my screen. Sorry. My apologies. Thank you. Yes. So there we go. I can't believe I did that. Let me just backtrack a little bit. I'll just repeat what I just said. I'll do my best to repeat it. All right. So we know the vertex. The vertex form is that y equals ax minus a squared plus k. The vertex at 2, 1. And there's another point at 3, 0. So if we replace h with 2 and k with 1 to get this, plug in the other point on the graph. You can also plug in 1, 0. It's up to you. But any point you can identify, plug it in for x and y. And then work it out. You should get a plus 1 equals 0 or a equals negative 1. So the equation of the graph would be y equals negative parentheses x minus 2 squared plus 1. That's all. Now, next up, vertex is 3, negative 1. There's a point at 4, 0. So you do the same thing. Do exactly the same thing. Y equals a. Plug in 0 for y and 4 for x. You should get a equals 1 if you solve it correctly. So it's y equals x minus 3 squared minus 1. That's all. That should be pretty easy. Now, the right intercept form, I mean, that's easy too. That's just y equals x minus 1, x minus 3. But the other one's y equals x minus 2, x minus 4. Okay, cool. Now, see, I don't give you a graph. We can do this. If these are your x-intercepts, you're going to do x minus negative 11, x minus 3. You don't know what a is, but you're going to plug in negative 192 for y and 1 for x. And a is going to be 8, I think. Yeah. So when you pass it to another point, you plug it in for x and y and solve for a. That's what you want to do. So you plug in the x-intercepts. That's easy. In intercept form, I didn't really talk about this, but an intercept form could be thought of like this. Where P and Q are the x-intercepts. So you can think of it like that if you want. Okay. On the last page, let's do 4 and 5, then we'll do homework after that. I'm gonna trim the homework too. I printed, but it looks a little too much. Standard form, I'd multiply that out first. Then distribute the 2. That's it. Here I'd expand x minus 2. Hey, I'm good. Yeah, actually, let's do it after this. Yeah, actually, sorry. Yeah. No, I talked about that. Distribute. And then combine like terms. That's a plus. Sorry, that looks messy. There you go. Okay. As for problem sets, yeah, print some stuff here. I'll hand it to you guys just so you have it. I'll suggest problems, but this is gonna be wise for you. You can choose what you want to do. If you want to do delta math, I think that would make sense. We'll do that tomorrow also. Yeah, that's right. Yes, just problems. If you've done delta math, great. But yeah, we can do that too. No, it's not all. No, not even close. No, because it's a little much.
I mean, really. Oh, I thought, oh.
So for 4.1. Numbers 3 through 6, all. Then for 4.2.
You know this.
Yeah, we didn't do word farm today, so it's number 1 to 2 all. Yeah, that's all.
Wait, so it's just 3
to 6 on the first page, yeah. And then 10 through 1 to 10. And if you want to do delta math, go for it. Ask a question if you're stuck. I'll come by.
I don't know, yeah.